In this session, we shall learn about binomial theorem. We shall discuss with the salient features of binomial theorem. Let us first of all know what is meant by binomial theorem. Say this is x, a single expression containing only one term. It can also be called a monomial. You consider this x plus y. This is an expression containing two terms. It can also be called a binomial. You consider this x plus y plus z. It can be called a trinomial, like that x1 plus x2 plus x3 plus etc. plus xn. This can be called a multinomial. Okay, we could have understood the word binomial. We are now ready to take interest to deal with the study of the binomial x plus y. Okay, what is x plus y whole to the power of 1? It is x plus y. What is x plus y whole square? It is x square plus 2xy plus y square. What is x plus y whole cube? X cube plus 3x square y plus 3xy square plus y cube, isn't it? By x plus y, it needs no proof at all. If you can multiply x plus y into x plus y, you'll be able to have this. Similarly, x plus y whole cube is multiply this with x plus y, you'll be having it. And again, x plus y whole to the power of 4, suppose it is asked. Then x plus y whole square. It can, or x plus y whole cube into x plus y. That can also be obtained like this. X to the power of 4 plus 4x cube y plus 6x square y square plus 4xy cube plus y to the power of 4 and so on. Suppose I need to have x plus y whole to the power of 10. Then proceeding in this way is of course a tedious job to multiply with x plus y into x plus y into x plus y 10 times. So far, the higher indices, that is if the index is a higher number than this, we need a particular format or a procedure. Let us study all these things. Whole power 1, in this 2 terms are there. Whole square, we are having 3 terms. Whole power 3, we are having 1, 2, 3, 4 terms. Whole power 4, we have 5 terms, isn't it? Moreover, you can study one more thing. Whole square, full exponent 2 is given to x. 1 is reduced and is supplied to y. Full is supplied to y. Here, observe the powers of x. 3, 2, 1, 0. Powers of x will be going on decreasing. Powers of y, 0, 1, 2, 3 is in an increasing mode. Just like the observe this x plus y whole to the power of 4, 4, 3, 2, 1, 0 with respect to the powers of x. And with respect to the indices of y, 0, 1, 2, 3, 4. These are all the pieces of observation that we must keep in mind to have the formula for x plus y whole to the power of n, where n is a natural number. If n is a natural number, then the formula or the statement of x plus y whole to the power of n is called binomial theorem for positive integral index. If n is a negative integer, then that statement can be called binomial theorem for negative integral index. If n is a rational number, then we say that statement to be the binomial theorem for a rational index. Well, we shall look at those things in an order. Let us first of all think of binomial theorem with positive integral index. Let us now observe the statement regarding binomial theorem for positive integral index. If x, y belong to R and n belong to n, x plus y whole to the power of n is given by. You please observe the style of obtaining it. The full exponent n is given to be to x first of all, and then 1 is reduced and given to y. Another one more is reduced given to y. Exponent r is reduced and it is given to y, and so on. Full power is full exponent is given to y. These are the required number of terms. You observe the nature. Powers of x are continuously decreasing and the powers of y are continuously increasing. And at any cost, at any stage, sum of the exponents of x and y is 1. You can observe it. 1, 1, 1. N it is. Sum of all the expressions, sum of the exponents of x and y in every term is n. Okay, how many such terms are there? Let us start counting from nc0 plus nc1 plus nc2 into x power n minus 2 into y square and so on, ncr into x power n minus r into y power r plus ncn into x power 0 into y power n. You count the coefficients here, nc0, nc1, nc2, nc3, etc., ncn. How many are they in number? They are in n plus 1. They are n plus 1. Excluding this 1, 2, 3, etc. There are n terms, and with nc0, so totally there are n plus 1 terms in this expansion. Well, what do you mean by nc0, nc1, nc2 and so on, etc. ncn? These are just nothing but meant in the same way as we could do in the chapter permutations and combinations. What is NCR in general? NCR is equal to n factorial by r factorial into n minus r factorial, and all the properties of those coefficients NCR will be recollected from the chapter permutations and combinations, namely NCR is equal to NCn minus r, NC0 is 1, NC1 is n, like that. Well, this is the statement of binomial theorem for positive integral index. X plus y whole to the power of n is equal to nc0 into x power n, and if you want you can write x power n into y power 0 also here. There is no harm in writing that, because as we could see x power 0 into y power n in the last term, there is no sin and there is no objection to have y also in the first place with the exponent 0, y power 0. So altogether, how many terms are there in this expansion? N plus 1 terms are there, and these coefficients nc0, nc1, nc2, etc., ncr, ncn are termed as binomial coefficients hereafter, because they could be used in the statement regarding binomial theorem. They could be recalled again as binomial coefficients. They're called binomial coefficients. That's it about x plus y whole to the power of n. Now, it is our duty to recall the properties of this NCR and to study the main, or rather salient features of this statement. We're now going to do that. Let us now recall the properties of these coefficients, namely NC0, NC1, NC2, etc., etc. Look here, NC0 is equal to 1. This is again NCn. N minus 0 is NC1 is n. This is again NCn minus 1. NC2 is equal to n into n minus 1 by 2 factorial, and it can again be written as NCn minus 2. Like that, NC3, let us recall the formula, or rather definition. This is nothing but by 3 factorial. This is again written as NCn minus 3, and proceeding in this way, we can also write NCR is equal to NCn minus r, NCn minus r. These are the very basic definitions, or rather formulae of these binomial coefficients, isn't it? Well, moreover, while solving the problems, we should come across some more salient features, rather some more formula regarding these coefficients, namely NC0, NC1, NC2, etc., etc. What are they? We shall be looking at those properties now. This is one of the most useful and prominent results which we generally make use of in so many problems. NCR minus 1 plus NCR is equal to n plus 1 CR. Let's see, let us have an illustration here. 10C3 plus 10C4, 10, 10, same. 3, 4, differ by 1. That 1 is going to be added to this n so that it becomes 11C. 3 or 4, which is bigger? 4 is bigger, so 11C4. Just like that, you observe the same thing here also. N, same. R minus 1 and R differ by unity, that is 1. That 1 is going to be added to n so that it becomes n plus 1 CR, because between R minus 1 and R is bigger, isn't it? Like this we make use of. As another example, let me have 12C5 plus 12C6 is, come on, 13C6. 15C8 plus 15C7, come on friend, this is nothing but again 16C8. It is 16C8. Like that we make use of this. One more result we shall point out. Another useful result, NCP is equal to NCQ if and only if either P is equal to Q or P plus Q is equal to N. Of course, this has been derived from the identity NCR is equal to NCN minus R. If at all these two things happen to be equal, no problem. Otherwise, what happens? R is equal to N minus R if it is okay. Otherwise, other possibility is sum of these two is N. It is very easy to observe, isn't it? Well, NCP is equal to NCQ is equal if and only if it happens, if and only if either P is equal to Q or P plus Q is equal to N. One more important result, NCR by NCR minus 1 is equal to between R and R minus 1, which is smaller and which is bigger. R minus 1 is smaller, R is bigger. Write the bigger in the denominator, write the smaller in the numerator like this. N minus of R minus 1 is just nothing but N minus R plus 1 by R. Observe the style of obtaining it so that it becomes very easy, of course, to make use of it. 10C5 by 10C4. What is that? 10 minus 4 is 6 by bigger number is 5. That's it. Like that we make use of n minus of smaller number by bigger number. 10 minus 4 by 5. Another illustration we can see 12C8 by 12C7. How can you get it simplified? 12 minus 7 is 5 by 8. 12 minus 7 by 8. And the basic formula or rather result which we use is this. So this is also a beautiful result. Like this, if we proceed, a big list will appear before us, and the actual purpose of the present discussion is to go through the salient features of binomial theorem. We shall now look at the main features of the statement of binomial theorem. Yes. Well, let us rewrite the statement of binomial theorem with positive integral index. It is x plus y whole to the power of n is equal to nc0 into x power n into y power 0, of course, I am not writing, plus nc1 into x to the power of n minus 1 into y plus nc2 into x to the power of n minus 2 into y square and so on, plus ncr into x to the power of n minus r into y to the power of r and so on, NC n into x to the power of 0 into y to the power of n. What are the things that must be noted in this expansion? The first thing is, how many terms are there in the RHS of the statement? Of course, hereafter we call this the expansion of x plus y whole to the power of n. This expansion contains how many terms are there? It's very easy to count. If you close this, NC1, NC2, NC3 and so on, NCn, there are n terms. If you add this, n plus 1 terms will be. It contains n plus 1 terms. N plus 1 terms. Well, what is this? The first term is started with NC0. Second term starts with NC1. Third term starts with NC2. Fourth with NC3. Fifth with NC4. 10th with NC9. R plus 1th term starts with NCR. Yes, that is why this particular term is referred as the general term or R plus 1th term. This is starting with NC1, hence it is second term. What is that term which starts with NC5? Sixth term. What is the term which starts with NC10? 11th term. What is the term which starts with NCR? R plus 1th term. And this particular term is hereafter referred to as general term or R plus 1th term or standard term. Is given to be TR plus 1 is equal to NCR into x to the power of n minus r into y to the power of r. TR plus 1 is equal to NCR into x to the power of n minus r into y to the power of r. This is called either general term or R plus 1th term or standard term. This is the most standard or general term in the expansion. If at all you are required to have some, say, 10th term, imagine 10 in the place of R plus 1. Then what is R? 9. So with what coefficient it will be started with? NC9. Well, what is the fourth term? R plus 1 is 4. So R is 3. Fourth term starts with NC3. Come on, NC3 x power n minus 3 y power 3. Fifth term means R plus 1 is 5. R is 4. So NC4 x power n minus 4 into y to the power of 4. I require 10th term, you say. Then R plus 1 is 10, R is 9. So it should start with NC9 x power n minus 9 into y power 9, like that. There are so many usages for this particular expression, rather formula. That is why it is called the general term. It is called general term. Very important thing to be noted here is the general term. General term is TR plus 1 is equal to NCR into x power n minus r into y to the power of r. Yes. Well, let us now observe some examples to find the general term of a given expansion. As an example, we shall be going through some examples now.